Now, on the GMAT, right, when we speak about absolute values, we basically mean the mod of x, right? Now I'm going to start from scratch. Mod of any constant, say mod of 25, will always be positive, right? Mod, you've learned in school, whatever comes out of a mod will always be positive. So mod of any constant, mod of 25 will be 25, mod of minus 25 is also going to be 25. But when I ask you about what is mod of x, now things change slightly. The first definition of a modulus is the algebraic definition of a mod. Mod of x is defined as plus x if x is greater than 0, minus x if x is less than 0, and 0 if x is equal to 0. Now this is the algebraic definition of a mod. Now, most of you will be wondering, okay, modulus, you put a mod, everything becomes positive, then why are you saying it's plus or minus x? See, you don't need to look at it, especially when you're dealing with variables, right? You don't need to look at variables in terms of the output. For example, if I tell you x square is equal to 25, right? Most of y'all will tell me if x square is equal to 25, x is going to be plus or minus 5. Now, the reason you're going to tell me plus or minus 5 is if I put plus 5, I plug in x as plus 5 and I take whole square, I'm still going to get the output of 25. If I put minus 5 as x, I'm still going to get the output of 25. So when you're dealing with a variable, right, you're not worried about what the output is going to be. You are worried about the solutions to that equation. So I know that mod of x will always be 0 or positive, right? Whatever comes out of the mod is always going to be either 0 or positive. But you are not worried about the output. You're worried about the input, the solutions to x. So if I put x plus x inside the mod, do I still get the positive output? Yes. If I put minus x inside the mod, do I still get the positive output? Yes. So the solutions of mod of x is plus x and minus x. So whenever you're working with variables, right, whenever you're working with variables, you need to keep in mind that you're always looking at the solutions to the equation, not the output of the equation. So mod of x, the algebraic definition is plus x when x is greater than 0, minus x if x is less than 0, and 0 if x is equal to 0. Okay, with this first bit, guys, I just want to, put things out there because some of you all might have a very, very wrong perspective of what a modulus is, saying that, okay, I can just remove the mod and make it positive. You need to understand that mod of x is always defined as plus or minus x. Okay with this? Okay with this? Okay with this first bit, everybody? Quickly type in the chat window if it's okay. I'm going to continue from here. All right, perfect. Now, what do you think? And I want all of you all to give me an answer here. What do you think root of x square is? What do you think root of x square is? Would it be x or would it be something else? No. So most of y'all are giving me x. See, again, you're not taking back what I'm trying to tell you here. Remember, when you're dealing with a variable, you are never worried about the output. You're worried about the solutions to that equation. And the best thing to keep in mind always is this example, x square is equal to 25. When x square is equal to 25, you're going to say x is plus or minus 5, right? You're worried about the solutions to it. Root of x square is not only plus of x. Root of x square is plus or minus x. Okay? You don't cancel the root and the square and say the answer should be x. Whatever comes out of the root is positive. That's for sure. Root of 36 is 6. Root of 25 is 5. Root of a constant is positive. But root of a variable, again, you are not worried about the output. I know the output is always going to be positive. You're always worried about the input. So root of x square, for me to get a positive quantity, I can substitute x as plus x whole square, which will still give me the positive quantity. And I can also substitute x as minus x whole square, will still give me the positive quantity. So root of x square, by definition, is plus or minus x. The solutions of root of x square is plus or minus x. Okay? So don't be under the assumption that that this is like very, very simple algebra. Okay, you just cancel out the root and the square. What you've been taught in school, if you've been taught that in school, then it's completely blatantly wrong. Remember, whenever you work with variables, whether it's a mod, whether it's a root, you're always worried about the solutions to that equation, not the output. So mod of x is plus or minus x. Root of x is also equal to plus or minus x. So clearly, since both give me plus or minus x as the outputs or the solutions, I have a very, very important relationship here. Mod of x is equal to root of x square. Okay? Mod of x will always be equal to root of x square because they both give me the exact same solutions. That is, it gives me plus x when x is greater than 0, minus x when x is less than 0, and 0 when x is equal to 0. So a very, 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 very important concept is that mod of x is always equal to root of x square. Okay? So three things you have to hold on to here. Three things you have to hold on to here. One, the definition of mod of x in the algebraic form. Second, what is root of x square? Root of x square, keep in mind, is always plus or minus x. And third, the relationship between mod of x and root of x square. Mod of x will always be equal to root of x square. Okay, guys? Okay, for those who gave me x as the answer, right? That's completely wrong. You need to keep this in mind. Mod of x is always root plus or minus x. Root of x square is always plus or minus x. Now, this is one way. This is one way of defining a modulus. Okay, and that's the algebraic definition of a mod. For example, if I give you mod of x equal to 5, and if I ask you to tell me what would be the solutions of x, most of you all are going to do this. You're going to split open the modulus based on the algebraic definition we discussed. So mod of x is plus x when x is greater than 0, and mod of x is minus x when x is less than 0. So you're going to say mod of x equal to 5, so x is going to be equal to 5, or minus x is going to be equal to 5. Or most of you all would do this, mod of x is equal to plus or minus 5, right? Or x is equal to plus or minus 5, and then you would solve for x. Now clearly here you're going to get two solutions. X is 5 and x is minus 5. And you'll realize that the two solutions is, if I put 5 inside the mod, I'm still going to get the output 5. If I put minus 5 inside the mod, I'm still going to get the output 5, right? Now this is how you can solve a modulus, by splitting open the modulus using the algebraic definition. But you can also define a mod on the number line. You can also use a number line approach to solve a modulus question. I'll work the same question, mod of x equal to 5, on the number line. Now the modulus on the number line is defined as the distance from the origin. Now what do you mean by the origin? If I have a mod of x term itself, where x is not attached to some constant, then we say that the origin is at 0. But say if I have something like mod of x plus 2 is equal to 5, then if x is attached to any constant here, for example x plus 2, then we say that the origin is at minus 2. We just put this entire quantity to be 0 and we find the origin. So the origin here is at minus 2. And finally, if I say mod of x minus 2 is equal to 5, then we say that the origin here is at 2. So basically, one way of definition of a mod is the algebraic definition. The second is always to learn mods in terms of the distance from the origin on the number line. So if I take the first equation, right, mod of x is equal to 5, the origin here is at 0. Now this is how you read a mod in terms of a number line, in terms of distance. The distance from the origin is given to me as 5 units. Now the origin here is at 0, and I need to travel a distance of 5 units. So I can do this in two ways. I can travel a distance of 5 units to the right, and the endpoint here is going to be plus 5. And I can also travel a distance of 5 units to the left, and the endpoint here is going to be minus 5. So the endpoints here are the solutions to that modulus. Similarly here, mod of x plus 2 is equal to 5. I know that the origin is at minus 2. So this is how you read this mod. The distance from the origin, that is minus 2, has to be equal to 5 units. So from the origin minus 2, I need to travel 5 units to the right. If I travel 5 units to the right, I'm going to end up at plus 3. Or I can travel 5 units to the left, where I'm going to end up at minus 7. So minus 7 and plus 3 are the solutions of this modulus. And finally, mod of x minus 2 is equal to 5. I know that the origin is at 2, so the distance I need to travel now from the origin 2 is 5 units. So 5 units to the right plus 7, 5 units to the left, which is minus 3. That would be the two solutions of the mod, right? So the second alternate way of defining a mod is to represent modulus on a number line, where modulus is defined as the distance from the origin on the number line, right? So there's always two approaches to solve a mod. One is to use the algebraic approach of splitting open the mod based on plus or minus. And second is the number line approach of solving the mod, where you always take the distance from the origin. Okay with this, guys? Okay with the second definition of mod, the number line definition of mod? All of you all? All right, perfect. Now, okay, so what I've done, right? What I've done is I'm going to shift to a new sheet here. What I've done is I have split modulus questions into 5 types. Okay. The first type of a modulus question, that would be type 1, would be of this form. Say mod of something equal to something, right? For example, say mod of x plus 1 is equal to 4x minus 3, right? So the first type of question would be mod on one side, right? Mod of something equal to something. Now what I want all of you all to do, or let me, before I ask you to work this out, whenever I encounter a question which falls in the bucket of type 1, I would always prefer to use the algebraic approach of solving the mod. I told you there are 2 approaches to solve the mod, okay? Don't be rigid in your approach and say, I'm going to only solve modulus using algebra, only solve modulus using the number line. That would be a very, very bad strategy to go with. It's always better to juggle between the procedures of working, okay? There are some cases where the algebraic approach would make sense. There are some cases that the number line approach would make sense. So I'm telling you that when you deal with a question of type 1, when you have mod of something equal to something, it always makes sense to go with the algebraic approach of the mod. And what is the algebraic approach of the mod? You split open the mod based on the definition that mod of x is plus x when x is greater than 0 and minus x when x is less than 0. So I want all of you all to take a quick 30 seconds. I want all of you all to split open this mod and quickly give me what would be the solution or solutions for x, please. Okay, so most of you all are giving me 4 by 3 and 2 by 5, but I'm telling you that both of them are not the solutions to the mod. Okay, that would be a wrong answer. What you all are giving me is a completely wrong answer. Now, this is where I want you to be a very, 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 very careful. Okay, now listen to me very carefully and how you solve the type 1 set of questions. Now, I have mod of x plus 1 is equal to 4x minus 3, right? I'm going to split open this modulus based on the definition. So I'm going to get x plus 1 is equal to 4x minus 3. That would be one equation. And I'm also going to get minus of x plus 1 is equal to 4x minus 3. That would be the second equation. Now I'm going to solve for this. I'm going to get 3x is equal to 4. So x is going to be equal to 4 by 3. And here I'm going to get minus x minus 1 is equal to 4x minus 3. So 2 is equal to 5x. So x is going to be equal to 2 by 5. Now, both of these values are not solutions to the mod. Now, all of you all, or not all of you all, maybe a couple of you all have given me the right answer. Most of you all have made this mistake. You'll have stopped solving this question after you got these 2 solutions. Now, this is the extra step that you need to do. You have to make sure that once you solve the 2 equations and you get a value for x, you have to cross check whether the values of x satisfy the main equation or not. It is mandatory that you have to satisfy the equation. X doesn't lie between these two. I mean, it's not an inequality. So don't bring in those concepts, please. The point I'm making here is once you solve for the equations, you have to make sure you plug in the values back into the main equation and check if those values satisfy the equation. For example, if x is 4 by 3, I'm going to say 4 by 3 plus 1. Mod of 4 by 3 plus 1 is 7 by 3. And 4 into 4 by 3 is 16 by 3 minus 3. So 16 by 3 minus 3 is going to be 16 minus 9 by 3, which is 7 by 3. So the first equation, x is equal to 4 by 3, absolutely satisfies the main equation. I know that is going to be a legitimate solution to that mod. But if I take x is equal to 2 by 5, right, and I put it into the equation there, 2 by 5 plus 1, mod of 2 by 5 plus 1 is going to be 7 by 5. But 4 into 2 by 5 is going to be 8 by 5. And I have to subtract 8 by 5, I have to subtract 3 from 8 by 5, which will give me minus 7 by 5. In math, 7 by 5 can never be equal to minus 7 by 5. So you need to discard the solution x is equal to 2 by 5. So the only solution to this entire equation is the solution x is equal to 4 by 3. Okay, so I'm going to just give you like a brief explanation in a nutshell quickly. First, whenever you see a question of a modulus which falls under type 1, and type 1 would be mod of something equal to something, the first step is to use the algebraic approach of the mod, split open the mod. Second, solve for x or solve for the variable. And finally, and the most important, make sure you cross-check with the main equation. You have to do that extra step of cross-checking with the main equation. Okay? So not always will you get two solutions to the mod. You might get two solutions, you might get one solution, you might not get any solution also. Okay, so it's mandatory that once you solve, you have to cross-check with the mod. Okay with this, guys? Okay with this, all of y'all? Can anybody tell me why do you have to cross-check? Why should I do this extra step? Normally, while solving solving quadratic equations, you don't do it, right? I mean, normally you take it to be take it as a given that there's going to be two solutions. Why do you have to cross-check here and cross-check if both the values are equations? Can anybody explain to me quickly? Type out. Why do we have to cross-check? Nobody? Perfect answer. That's perfect. Now, the reason why you need to cross-check is because of this, okay? I don't want all of y'all to, utilize this procedure of solving that I'm going to tell you it now, right? All you have to do is do what I've done as a working procedure to solve that previous question, okay? I'm just going to explain to you why do we have to cross-check. You see, mod of x, the definition is plus x when x is greater than 0. It's dependent on this condition. And mod of x is minus x when x is less than 0. It's dependent on this condition, right? So when I have mod of x plus 1 is equal to 4x minus 3 is equal to 4x minus 3. The reason why you're working with the algebraic approach is it's because it makes it easier for you to split open the mod. But you need to understand you have to satisfy the actual definition of mod. So mod of x, in this case, x is x plus 1. Mod of x is plus x when x is greater than 0. That is when x plus 1 is greater than 0. What comes out of this mod would be a positive x plus 1. Or when x is greater than minus 1. So if when I solve the equation, I got the solution for x here to be 4 by 3. Now you'll realize here 4 by 3 satisfies the condition that it's derived from. X is greater than minus 1 should be the condition. 4 by 3 is definitely greater than minus 1. But if I take the second case, right, mod of x is minus x when x is less than 0. So what comes out of the mod here is minus of x plus 1 when x is less than 0. That is when x is less than minus 1. So mod of x plus 1 will give you minus of x plus 1 when x is less than minus 1. And when we solve this entire equation, we got x to be equal to 2 by 5. And you'll realize that this 2 by 5 does not satisfy the condition that it's derived from. 2 by 5 is not less than minus 1. That is why we discard this entire solution. Okay, you don't need to sit and actually figure out whether it's greater or lesser and so on. I'm just asking you to do this. I'm asking you to split open the mod based on the definition, solve the equation, but the extra step to make sure that you get the exact solutions, you cross check with the main equation. Okay with this, guys? All of y'all okay with this? Perfect. Yes, Sandeep, what you said is right. You can also utilize it on the number line, but I would prefer not to use the number line when I have an equality, right? I would prefer to use the number line when I have an inequality, okay? And it becomes easier for you to work it. Yes, you can definitely have the first step as 4x minus 3 is greater than or equal to 0, right? I would definitely go that route if it was a data sufficiency question and asked me something about x, right? But it was asking me for an exact value for x, isn't it? So 4x minus 3 greater than or equal to 0 does not give me an exact value for x, isn't it? That's why I did not, go the analysis route of what you did. Okay, I actually solved for x here. All right. So that's type 1. That's type 1. Now let's look at what type 2 is. So type 2 would be a modulus question of this form. Mod of something, inequality, something. Mod of something, inequality, something. Okay, that inequality can be anything. It can be less than, it can be greater than, it can be less than or equal to, it can be greater than or equal to. Nothing changes, right? Now, let's take an example. Okay, let's take an example. Say mod of x plus 2 is less than 8, right? Now, before I go into the working of mod of x plus 2 is less than 8, whenever you see a question which falls under type 2, that is mod of something, inequality something, I will never go the algebraic route, but I'll always go the number line approach. I'll always use the number line approach to figure out what the solution to this equation is going to be, right? So let's look at the number line in terms of an inequality. When I told you mod of x is equal to 5, I said the definition was you're going to travel a distance of 5 units from the origin, which was 0. So we got plus 5 and minus 5. And these endpoints were the solutions to the mod. But if I change this to mod of x less than 5, right? And if I plot everything on the number line, the origin is still at 0. But this time, we are traveling a distance of less than 5 units. So if I'm going to travel a distance of less than 5 units, the boundary conditions are going to be at plus 5 and minus 5. And if I have to travel a distance of less than 5 units, I can travel to any point in between minus 5 and plus 5. Agree? If I have to travel a distance of less than 5 units from the origin, I can travel to any point in between minus 5 and plus 5. So if mod of x is less than 5, then the range of x will always be from minus 5 to plus 5. So putting this in a general form, if mod of x is less than a, the range of x will always be from minus a to plus a. If mod of x is less than a, the range will always be from minus a to plus a. Let's take another condition. Okay, say mod of x is greater than 5, right? Again, I'm plotting things on the number line. The origin is at 0. And this time I'm traveling a distance greater than 5 units. So the boundary conditions are going to be plus 5 and minus 5. And if I have to travel a distance greater than 5 units, I'm going to travel from 5 to infinity and minus 5 to minus infinity. So if mod of x is greater than 5, the range of x is going to be x greater than 5 and x less than minus 5. So writing a general form, if mod of x is greater than a, the range will always be x greater than a and x less than minus a. So what do you do? What do you do for type 2? Very simple. Whenever you see a question which falls under type 2, that is mod of something, inequality something, you use the general forms. It's always easier for you to use the general forms. You don't even have to put everything on the number line and work it out. What are the general forms? Mod of x less than a. The range when mod of x is less than a would be always between minus a to plus a. And mod of x greater than a would give you a range of x to be greater than a and x to be less than minus a. Okay? So mod of x less than a and mod of x greater than a. That's how you would look at type 2, right? So any question under type 2, all you have to do is use the general forms of mod of x less than a and mod of x greater than a. If you do so, things become very, very easy for you to solve. So if I give you mod of x plus 2 less than 8, quickly, either you can plot everything on the number line and figure it out, or just say here mod of x less than a, the range is from minus a to plus a. A here is x plus 2, a here is 8, x here is x plus 2, a here is 8. So the range is going to be from minus 8, less than x plus 2, less than plus 8. So remember, when you get an inequality, right, you always try to solve for the variable, right? So I need to isolate the variable. I can do so by subtracting 2 throughout, because you can always add any quantity or subtract any quantity on both sides of an inequality, right? Or on all sides of an inequality, provided the inequality sign remains the same. So this is minus 10 less than x less than 6. That would be the solution to this modulus. Okay with this, guys? Mod of something, inequality something. Yes? Perfect. Yes, Himanshu, what you said is right. X plus 2 is less than 8 and x plus 2 is greater than minus 8. So that's one way to look at it. That's one way to look at it. Right? I'm not splitting open the modulus. I'm telling you this, right? It becomes too problematic if you have more variables and you have an inequality. So I would prefer to use the number line approach or the general forms. No, I'm not asking you to mug it up, Sandeep. I would definitely use the number line and figure it out, right? I'm just giving you a working procedure. The only working procedure you need to hold on to here is whenever you have a mod on both sides, mod on one side of an equality, you split open, use the algebraic approach. You have mod with an inequality, use the number line approach, right? I would prefer to do it on the number line. So if I have something less than, right, it would always be the range in between the extremes. If it is greater than, it would be the extreme ranges from x to infinity minus x to minus infinity. Okay with this? Perfect. Okay, so that's type 2. All right, so type 1, type 2. Now, to speak about type 3, right? To speak about type 3, I need to explain something called the concept of, or to speak about type 3 and type 4, I need to speak about the concept of a quadratic inequality. Okay, because you need to know how to solve for quadratic inequalities to understand what I'm going to do when you have modulus on both sides, right? For example, if I give you x square minus 5x plus 6 is less than 0, and I ask you, what should be the solution for x? Now, obviously, most of you all will do exactly what you do when you have a quadratic equality. You're going to factorize the left-hand side. So this would be clearly x minus 3 into x minus 2 is less than 0. And now some of you all at this point would say, you would analyze this entire equation and say, if this product has to be less than 0, one has to be positive, one term has to be positive, and one term has to be negative. And you would take two cases and then you would solve for these two cases, right? You actually don't need to take cases and solve for these two cases. You can always make use of a quadratic inequality concept. And the most important aspect is the quadratic inequality concept can be used even for cubic equations, even for fourth power equations, fifth power equations, and so on. For example, this is how we would solve. The first step is to draw the number line and put down the roots of this equation. Now, if I'd given you this equation as a quadratic inequality, then you would tell me if this was equal to 0, the roots here are going to be 3 and 2. So you're going to place the roots on the number line. This is 2 and this is 3. Now, after you place the roots on the number line, the default process is you start from the extreme rightmost region. What happens, right, when you put the roots on the number line is divided into 3 portions. This is the first, this is the second, this is the third. You always start from the extreme rightmost region And by default, you place the sign of the extreme rightmost region as positive. And then you go on switching between the signs. So this would be plus, minus, plus. It's a default procedure of working. If you want me to justify this, then it's easy for me to justify. If I take any value to the right of 3, say I take 4, and I put it into this equation, x minus 3 into x minus 2 is less than 0. 4 minus 3 would be positive. 4 minus 2 would be positive. So positive into positive will always give me a positive output. So I'm always going to get the sign of this extreme rightmost region to be positive. If I take anything between 2 and 3, that is 2.5. 2.5 minus 3 is going to be negative. 2.5 minus 2 is going to be positive. So negative into positive will always give me negative. So this region is going to be negative. And if I take any value to the left of 2, say 1, and I plug it into this equation, 1 minus 3 is negative. 1 minus 2 is also negative. Negative gives me positive. So this region will always be positive. So instead of you sitting and calculating all of this, right, just put the roots on the number line, right? Actually, in mathematical terms, we call these the critical points. So you put the roots on the number line. You start from the extreme rightmost region by default always. You place the extreme rightmost region as positive and then go on flip-flopping between the signs, switching between the signs. Once you do that, the last step to get your answer would all depend upon this right-hand side of the inequality. The right-hand side of the inequality is the most important. They are asking me to find out the solution for x, where this product x minus 3 into x minus 2 is less than 0. So if the right-hand side is less than 0, I need to consider, or my solutions are going to lie in the negative portions of the number line. And if this right-hand side was greater than 0, then my solutions are going to lie on the positive portions of the number line. So here, since I have x minus 3 into x minus 2 to be less than 0, the solutions for x here has to be any value of x between 2 and 3, this portion of the number line where all values are going to be negative. And if the question had given me x minus 3 into x minus 2 to be greater than 0, then I'm going to say that the solutions are going to be in the positive portions of the number line. So x has to be greater than 3 to the right of 3, and x has to be to the left of 2, that is x less than 2, right? So that would be the procedure to solve a quadratic inequality. Okay, very simple, very simple, and it's going to be very useful because you can also utilize it for a cubic inequality, fourth power inequality, and so on. Right? So don't get confused even if I give you less than or equal to. Okay, if I give you less than or equal to, you're just going to include the equal to sign in the solution. If I give you greater than or equal to, I'm going to include the greater than or equal to sign in the solution. Nothing changes. Okay, it's not different for less than and less than or equal to. It's exactly the same. Okay with this, guys? Just for you to get a better understanding of things, right? I'll give you a cubic equation and show you how easy this becomes. Suppose I give you x plus 3 into x minus 4 into x plus 2 is greater than or equal to 0. And I ask you to solve for x. So quickly, I'm not going to sit and worry about what are the signs of each of the quantities. That's too problematic here, right? So quickly, I'm going to plot the number line. And I'm going to place the roots on the number line. So the roots are minus 3, minus 2, and 4. Now these three roots are going to divide the number line into 4 regions. The region to the right of 4, between minus 2 and 4, between minus 3 and minus 2, and to the left of minus 3. I'm going to start with the extreme rightmost region, place that as positive, negative, positive, negative. I'm going to look at the right-hand side of the inequality. It tells me the product has to be greater than or equal to 0, so my solution has to lie in the positive portions of the number line. So the solutions here are going to be x going to be greater than or equal to 4, and x in between minus 3 and minus 2, inclusive of minus 3 and minus 2. That would be the solutions for this cubic inequality. Okay with this, guys, all of you all? Very important concept. Very important concept. I'm going to utilize this in modulus. All right. Everybody else okay with this? Can I move on? All right. Okay. What didn't you understand 1 plus 5? So if you can explain, if you can tell me what didn't you understand in this, is just that you put the roots on the number line, you start from the extreme rightmost region, you put it as positive, you switch between the signs, you look at the equation that is given, the right hand side is greater than or equal to 0, you consider the positive portions. If it's less than or equal to 0, you consider the negative portions. So if you can tell me what you didn't understand, that would be better. All right. Okay. So this would be type 3. So what I'm going to do is I'm going to write down type 3 and type 4 together so that you understand how to solve both. There's a big similarity between the two with only one difference. Okay. Now type 3 would be mod of something equal to mod of something. Basically, I'm going to have mod on both sides of an equality. And type 4 would be of the form mod of something inequality mod of something. Right? Mod of something inequality mod of something. Now the basic rule for solving any question where you have mod on both sides, whether it's an equality or an inequality, the basic rule is to square both sides and remove the mod. The basic rule is always to square both sides and remove the mod. Now, why do you do this? Why do you do this? Why do you square both sides and remove the mod? Because of the relationship mod of x is equal to root of x square. I can always represent a mod with a root. So to remove the root, I need to square both sides. So this is how you would, solve this entire equation. For example, if I give you mod of 2x plus 3 is equal to mod of x plus 1. Now, one way to solve this is to go the algebraic route, split this up into 4 equations, right, and then work with it. Actually, you don't need 4, you need 2 only. But some people would definitely split it up into 4 equations. You don't need to do such tedious work, right? I'm saying whenever you see mod on both sides, you just square both sides and remove the mod. So I'm just squaring both sides and removing the mod. So 2x plus 3 whole square is going to be equal to x plus 1 whole square. Why am I doing that? Because of this relationship. Mod of x is equal to root of x square. So I'm representing this mod of 2x plus 3 as root of 2x plus 3 whole square, and this as root of x plus 1 whole square. And if I square both sides, the root gets removed, right? So 2x plus 3 whole square is going to be x plus 1 whole square. Now this I know how to solve. This would be a quadratic equation, right? So 2x plus 3 whole square minus x plus 1 whole square is equal to 0. I'm not going to split open this square and then rearrange the terms and then solve the quadratic. Okay, I'm just taking the right hand side to the left hand side, and I'm using a square minus b square. Now a square minus b square is a plus b into a minus b. So 2x plus 3 plus x plus 1 and 2x plus 3 minus x minus 1 would be equal to 0. So 3x plus 4 into x plus 2 is equal to 0. So clearly here I have two solutions, x is minus 4 by 3 and x is minus 2. So both these values are solutions to this modulus. You don't need to bother about cross-checking because it's mod on both sides, right? So the outputs on both will always be positive. So you're not going to get one side which is positive and one side which is negative for you to eliminate the solution. So you don't need to cross-check here. You just need to solve the quadratic, get the two values for the mod, and get to the answer. The same thing you would do, even if you had an inequality. Say the same question, if I take it to be an inequality, I'm going to square both sides and remove the mod. So I have 2x plus 3 whole square minus x plus 1 whole square is less than 0. I'm going to do the same working here. And the last step would be this. 3x plus 4 into x plus 2 is less than 0. Now instead of equal to 0 here that we got, I've got this to be less than 0. And we just discussed this previously, right? This here is a quadratic inequality. So how do I solve this quadratic inequality? I'm going to place the number line. I'm going to put the roots on the number line. The roots are minus 2 and minus 4 by 3. I'm going to start from the extreme rightmost region, place this as positive, and then switch between the signs. So plus, minus, plus. And if I look at the right-hand side of the inequality, it's less than 0. So my solution has to lie in this negative portion on the number line. So the solution to this modulus, or mod of 2x plus 3 is less than x plus 1, is going to be x is going to lie between minus 2 and minus 4 by 3. Okay with this, guys? All of y'all okay with type 3 and type 4? I've done type 3 and type 4 together so that you compare the two. The exact procedures of solving is the same. X plus 3 into x plus 2 will follow the same rule. What do you mean follow the same rule, Balal Hussain? Yeah, follow the same quadratic inequality rule. Definitely yes. Okay with this, guys? All of y'all? Perfect. All right. So just quick recap. What is type 1? Type 1 would be mod of something equal to something. What do you do when you have mod of something equal to something? You split open the mod, you solve, you cross check with the main equation. Don't forget to cross check. Second, mod of something, inequality something, you always use the number line approach to solve. Mod of x less than a and mod of x greater than a. I'll come to that, Stephen. I'm coming to that. Okay, I still have the last type left, no? So don't worry about it. Right. Finally, type 3 and type 4 is when you have mod on both sides of an equality. And when you have mod on both sides of an equality or an inequality, the rule is you square both sides and remove the mod. Okay, square both sides and remove the mod. Now there are obviously different more types of modulus, right? If it was a cat class, I would go into various other types. But on the GMAT, right? On the GMAT, they don't expect you to learn rules of modulus and so on. Okay, they don't expect you to do that at all. All they expect you to do is to logically figure out what the answer can be. It's mandatory you know how to work type 1, type 2, type 3, and type 4 because 95% of your questions will fall under one of these types. Okay, but the type 5 question, right, is a type of question which does not fall under one of these types, and this is where I would refer to this as a miscellaneous bucket. Okay, I'm going to call this a miscellaneous bucket. And Stephen, I think, gave an example for it. He said, what if I have mod of x plus mod of y is equal to 1? There are two ways you can work this, Stephen. You can actually split open mod of x, mod of y. X plus y is equal to 1 is one equation. Minus x minus y is equal to another equation. And then work with the equations, right? Now, the other way to think about this, right? The other way to think about this is also to use the number line. You can also say that the distance of x from 0 plus the distance of y from 0 has to be equal to 1 unit. Okay, basically x and y are at the same origin and the distance has to be 1 unit. So think about it. If the distance has to be 1 unit, either x has to be 1 or y has to be 1, or x has to be minus 1 or y has to be minus 1, right? That's one way to look at it. But I wouldn't prefer to, at this point, split open the mod, solve, or put things on the number line, right? And this is where I'm speaking about the miscellaneous bucket. If you're not able to categorize the questions on modulus under any one of the buckets that we discussed, type 1, type 2, type 3, type 4, then the best approaches to solve, especially on the GMAT, would be for you to either analyze the question, or the fallback approach is to always plug in values. The fallback approach would be to always plug in values. Okay. Looking at this itself, I know that the solutions I can get is x is minus 1, y is 0, x is 0, y is minus 1, x is half, y is half, x is 1 by 4, y is 3 by 4. I'm going to basically get a lot of solutions in this equation, right? Or I can just analyze the question. I can just analyze the question and realize that the value of x can be anything between 1 and 0, and the value of y can be anything between 0 and 1. Now there are two ways you can look at type 5 questions. Okay, I told you one is analyze, the other one is plugging in values. I prefer the analysis route because it makes things way simpler. Now, how do you use the analysis route? How do you use the analysis route? Suppose I give you y is equal to, say, mod of x plus 2. Now, obviously, most of y'all will say this falls under type 1. So this question falls under type 1. So I can split open the mod. I'll work with this. I'm going to take some questions after this, Himanshu. Okay. I have the exact same question in my set of slides, so you don't need to worry about that. Okay. I know most of y'all would have used resources where other resources, so I've made sure to keep those questions that you use and explain it in the procedures of working. Okay, I'll come to that. I'm coming to that. I have the exact same question in my slides. Okay, so just hold on for some time. Now, if y is equal to mod of x plus 2, if y is equal to mod of x plus 2, obviously most of you all will just jump the gun here and say y is equal to x plus 2 and y is equal to minus x plus 2. It's absolutely fine. But what's going to help you out, right, especially at questions of the higher levels, is how you quickly analyze certain things. Now, looking at this equation itself, and somebody touched upon this in the beginning itself, I know that y has to be positive, either 0 or positive. Looking at the equation, since y is equal to mod of x plus 2, y has to be either 0 or a positive quantity, because whatever value I plug in for x, y will never be negative. So looking at that, I know one definite piece of information, that y is positive. Okay. Let's take another example. Say mod of minus n is equal to minus n. I want all of you to analyze this equation. Okay, mod of minus n is equal to minus n, and tell me what can you analyze about n, please. Just think about it. Okay, always keep in mind, when anything is equal to a mod, that anything will always be positive. Not defined. How is it not defined? Perfect. Most of y'all are saying n is negative, right? Now, don't fall for this trap. N is negative or n can be 0. Don't forget 0, please. Okay, many people would definitely forget the usage of 0. So don't forget 0, right? So clearly, how are you getting this? How are you analyzing and getting to this is because of this, right? You know that if minus n has to be equal to mod of minus n, this entire quantity has to be 0 or positive. Let's take the positive case first. If the entire mod has to be positive and minus n has to be a positive quantity, n has to be negative, because minus of minus n only can give you a positive value, or n has to be equal to 0. If you're not able to analyze, right, if you're not able to quickly figure out what is positive and negative, like I said, the alternate approach would be always to plug in values. Minus n is equal to mod of minus n. Let me put n is equal to 2. Minus 2 is equal to mod of minus 2. Mod of minus 2 is 2. Minus 2 can never be equal to 2, right? So I know I cannot use a positive quantity. But if I use a negative quantity, n is equal to minus 2. Minus of minus 2 is 2. Mod of minus 2 is mod 2, which is 2. So 2 is going to be equal to 2. So n definitely has to be negative, or n has to be 0. See, one thing you should be very, very careful about, okay, when you're plugging in values, is don't forget to plug in for 0. That's the most important aspect. Okay, so always think about 0 every time. 0 should be the first approach of working. If some of you all have seen my the online videos, in one of the online videos, right, towards the beginning of data sufficiency strategies, I speak about this acronym ZONEF, and especially whenever you're thinking about plugging in values, you always keep in mind this acronym ZONEF. And I expanded ZONEF to be 0. This is 1. This was negative. E was extreme, and F was fractions, right? And I spoke to you in the video, and I told you that that I would always check for 0 and 1 first, because 0 and 1 is easy calculation, first of all, right? It's very easy for me to plug in 0 and 1 and to calculate very easily. And second is, I always check for 0 first, because there are a lot of traps with 0. A lot of traps with 0. Okay? So you'll have to be a little careful while you're solving inequality questions and modulus questions, not to overlook that zero. Okay. So the point I'm making here is when you're dealing with type 5 questions, right? When you're seeing a question of a miscellaneous bucket, you always try to analyze the question. How do you analyze the question? You try to see what variables are equal to a mod and try to see what is positive and what is not positive, right? And second, if you're not able to analyze still, you can always think about plugging in values, okay? And plug in values to work with the equation. How do we work with double mods? I already told you, Shikhar, that you square both sides whenever you work with mod on both sides, right? So are you saying double mods in an equation like this? Mod of x plus 1 is equal to 1. Yes. What is wrong in this? You keep this as y, right? It's just algebra, no? So I can keep y is equal to x plus 1 and say mod of y is equal to 1. So y is equal to minus 1. Y is equal to 1 or y is equal to minus 1? What is equal to 1 now? Mod of x plus 1 is equal to 1 and mod of x plus 1 is equal to minus 1. This can never hold good because mod can never give you a negative. So you'll just have to solve for mod of x plus 1 is equal to 1. Right? It's okay. Even if you have a double mod, no? Whatever is inside your first mod, you put it as some variable a or y. Break open that mod first. Then replace that y back by the original equation and then solve for it. Okay with this? You want me to do it step by step, or have you got the drift of what you need to do? Got the drift of what needs to be done, or you want me to work it step by step? All right, perfect. All the others, it's a good question that Shikhar has asked, right? If I give you mod of x plus mod of y is equal to 1, right? Like I said, there are two ways you can work this out. If I give you mod of x plus mod of y is equal to 1, there are two ways you can work this out. One is to analyze, the other one is to plug in. Okay. One way to work it out is to work with the four cases. The first case you have is x plus y is equal to 1. And the second case you'll have is minus x plus y is equal to 1. Right? The third case you have is minus x minus y is equal to 1. And the fourth case you'll have is x minus y is equal to 1. And then I can plug in values to solve. But this becomes a little tedious procedure to work. Right? So think about it logically. Okay, I'm going to put things on the number line. The value of x, if the first solution I can have is 1. If I take x as 1, y is going to be 0. I can also take x to be minus 1, y to be 0. I'll still get 1. So I know the range of x has to be from minus 1 to 1. Right? The range of x has to be from minus 1 to 1. And the same holds good to the range of y. The range of y also has to be from minus 1 to 1. I can take any value from minus 1 to 1 as long as I figure out what x is, right? I can't cross this range, because if I put x is equal to 2, think about this. 2 plus something will never be equal to 1, right? So I can't have a mod to be negative. So I know the range of x has to be from minus 1 to 1, and the range of y has to also be from minus 1 to 1. So quickly I know what the range of x and y are, and I can work with that, right? I don't need to definitely tell you what the equation is. So x is going to lie between minus 1 and 1, and y will also lie between minus 1 and 1. Yes? So I have multiple solutions here. I have multiple solutions, right? I can't get only one solution to the equation here, isn't it? I have multiple solutions here. 1, 0 is one solution, minus 1, 0 is the other, 0, minus 1 is the other, half and half is the other. But you'll realize, yeah, you'll have to look at the values of x and y, which because it's a limiting condition, no? Mod of x plus mod of y is equal to 1. You'll have to look at what values of x and y are going to give you that equation. Yeah, definitely equal to also. Equal to. I need to include these two values, right? So it has to be less than or equal to and less than or equal to. No, for any type, even if you have three separate modulus, right? You can work with that. That's not a problem at all. Fractions are taken care of, no, from -1 to 1. If I tell you on the number line values from -1 to 1, it is inclusive of all the fractions, isn't it? I can't use 0, obviously. 0 is not a value I can use. If I can't use 0 for both, no. So even fractions would hold good, no. From -1 to 1, I also have all the negative fractions. I also have the positive fractions, right? Okay with this, guys? I'm just saying it would be easier for you to plug in values quickly. And if you're smartly plugging in values, I would plug in values for x and y between 1 and -1 such that mod of x plus mod of y is equal to 1. Simple as that. Because that's I've written the 4 equations because these would be the 4 equations which represent this entire equation. See, I don't want to go into a modulus and a graphical representation. Okay, if I actually draw this, no, this is how the equation would look. Okay, this is how the graph would look. So if some people also use the graphical representation of mod, which I don't want to go get into because I don't feel it's important for the GMAT, right? So x plus y is equal to 1. It's like your coordinate geometry. This is an equation of a line. So I have 4 equations of a line which is going to give me a closed figure. So this equation mod of x plus mod of y is equal to 1 is actually this closed figure here, which is going to be a square. X plus y is equal to 1 would be 1 comma 0 and 0 comma 1. That would be the line x plus y is equal to 1. So if you draw that entire equation, right, this is the figure you're going to get. So I'm just saying, and you'll realize that the boundaries here that you're dealing with, the boundaries here you're dealing with is always from -1 comma 0 to 1 comma 0 and 0 comma 1 to 0 comma to 0 comma -1. So it's always for x between -1 and 1 and y between. No, I wouldn't definitely go the route of graphical representations. Okay, it's not going to be easy for me to plot this. It's not going to be easy for me to plot this, isn't it? That entire figure is going to be shifted depending upon what value is attached to x and y. So you don't need to go into the graphical representation here. It's something that I wouldn't recommend. You take a range and you think about values that you can substitute, right? So when you have a range for x, you can figure out. They're not going to give you. First of all, your question is a little vague, right? They're not going to ask you to solve for x and y here because I cannot solve for x and y. It gives me multiple solutions, right? So either they're going to give me some data sufficiency question related to that, or they are going to ask me to figure out what is the range for x and range for y. That's why I figured out the range. I can't get a definite answer, right, for x and y here. All right. Okay. So these would be the 5 types of a modulus question. Okay, so try to put it in one of the 5 buckets. That would be the best approach to work, and then try to solve a question. If you're not able to put it in the first 4 buckets, right, always think about going the route of plugging in or going the route of using, the analysis procedure of work. So here's the first question. I want all of you all to take 2 minutes and solve. I told you, Shikhar, that you can always put whatever is inside the double mods, you can put that as y. Okay, so I'll take this question up after we work this question, all right? So I want all of you to try this question. 2 minutes, we'll have a discussion on this question. Last 30 seconds. All right. So starting off with a very, very simple one. Starting off with a very, very simple one. Um I've been told that y is an integer, right? Most of you all have given me, some of you all have given me alpha, some of you all have given me delta, some of you all Charlie, some of you all echo. Fine. So if y is an integer and y is equal to mod of x plus x, is y equal to 0? Now the first statement says that x is less than 0. Remember the definition of mod of x, right? Mod of x is plus x when x is greater than 0 and minus x when x is less than 0. So the first statement tells me x is less than 0. Then y is equal to mod of x plus x becomes y is equal to minus x plus x, because whatever comes out of the mod when x is less than 0 is always negative. So y is equal to minus x plus x. So the first statement gives me a definite answer that y is equal to 0. So the first statement is sufficient. The two possible answer choices are AD. Right? Second, now I have y is equal to mod of x plus x. Right? Now think logically, right? They're telling me y is an integer. They're telling me y is an integer. And they've also told me from the second statement that y is less than 1. Now, if y is equal to mod of x plus x, whatever value you choose for x, whether it's positive, whether it's negative, whether it's positive fractions or negative fractions, the value of y will always be either 0 or positive. Think about it. I'm analyzing here. The obviously the question here, mod y is equal to mod of x plus x, does not fall under one of the four buckets that we are dealing with, right? So I know I need to go the analysis route or go the route of plugging in values. I would definitely prefer the analysis route here. So if y is equal to mod of x plus x, think about it logically. Whatever value you put for x, right? Whatever value, whether it's positive, negative, or 0, the value of y will always be 0 or positive. The output will always be 0 or positive. Agree with this, all of you all? Perfect. So if the output of y has to be 0 or positive, and the statement tells me that y is less than 1, and also tells me that y is equal to an integer, then the only possible integer that I have less than 1, which is going to be in between the range of 0 to positive, as y is 0. So the second statement also gives me enough information to say that y is 0. So both statements individually would be sufficient to solve. All right. So the answer here is delta. Okay, so what I've done is somebody had asked me this question again. Somebody asked me the question of mod of x minus mod of x square, right? I've kept this in the slides towards the end, so I'm going to give everybody a chance to solve that question. We'll solve that question and then we'll have a discussion in the end. All right? Okay, with this guy. So I'm going to move on to the next question. I'm going to make it slightly more challenging. So here's your next question. Again, you have 2 minutes to solve. Give me an answer at the end of 2. Okay, I've got around 15 responses. Okay, a good amount of y'all say Charlie, some say B, some say E, some even say C. Okay, fine. So let's work with this. Okay, let's work with this. What is the value of Y? Remember, this is a value data sufficiency question, so I need one definite answer, right? First statement says 3 mod of x square minus 4 is equal to y minus 2. And remember, you're working for y, so y is going to be 3 mod of x square minus 4 plus 2 is equal to y. Now, for those of you all who just wasted your time, putting in values for x or splitting open this mod and solving, it was just a waste of time. Because just looking at this entire question, right, I know that y has to be a positive quantity. Looking at this entire statement, I know y has to be positive, or in other words, y has to be a value which is definitely greater than 2, isn't it? I'm analyzing this entire question here. Y has to be a positive quantity. Think about it, right? Everybody okay with what I'm saying? Y has to be a positive quantity? Is that justified? I don't need to sit and solve for x and so on here, because the question clearly is asking me what is the value for y. So the value of y depends upon the value of x, and I can plug in any value of x that I want. So I'm going to get multiple possibilities, right? But I know the first statement gives me one very, very critical piece of information, that y is positive. Now let's take the second statement. Now the second statement tells me mod of 3 minus y is equal to 11. So if mod of 3 minus y is equal to 11, this falls under type 1. So I'm going to split open the mod, or looking at it only, you can solve for those of you are good at numbers. So I have 3 minus y is equal to 11, or minus 3 plus y is equal to 11. So y is going to be equal to minus 8, and y is going to be equal to 14. So both of these values are solutions to this equation, because if I put y is minus 8, I'll still get 11. If I put y is equal to 14, I'm going to still get the output to be 11. So the second statement also doesn't give me one definite value for y. So the second is also insufficient, right? BCE, out goes B. Now when I combine the two, this is where things become way simpler if you would analyze the first statement carefully, right? The first statement tells me y is positive, and the second statement tells me y can be minus 8 or 14. Now, if I need to combine the statements, I need to satisfy the information given in both statements simultaneously, right? So if y is positive and y is minus 8 or 14, the only possible value for y has to be 14. So the answer here is Charlie. Okay with this, guys? All of you all? Okay with this? Okay with how I analyze? Won't substitute the value of y. Where would I want to substitute the value of y? Yeah, if we substitute the value of y, it will still satisfy, right? It will still satisfy the main equation. Why should I substitute the value for y in the first equation? The question is not asking me to find the value of x, isn't it? This question is asking me about y, so why should I solve for x? Okay with this, guys? Perfect. So I'm going to move to the next question. So here's the next question. Mod 3 minus y when y is equal to 14 is mod minus 11. Mod of minus 11 is 11 only, Raj. So it still satisfies the equation, right? Mod of minus 11 is still 11, right? It's not changing anything, no? So both the equations y is equal to minus 8 and y is equal to 14 satisfy the equation that is given, correct? All right. So here's the third question. Again, I'm going to give you a minute and a half, 2 minutes to solve. Why would I combine the statements? See, when I'm combining the statements here because we need to use both statements simultaneously, right? You combine the statements when you eliminate the two statements individually, right? You can't jump to an an answer. You'll have to work with the statements individually. eliminate the statements individually, and then you'll have to combine. Okay, you can't just jump on a data sufficiency like that. Data sufficiency states that the answer will be A or B only if you check for the statements individually first. Then only if the individual statements are insufficient, that's when you combine the two. Okay, I think you're 1+5. I think you're new to the GMAT, so I think you don't know what A, B, C, D, and E mean. So I think it's better for you to have a look at the question, a question type of data sufficiency. You'll understand what A, B, C, D, and E mean. Okay. Guys, what do you think would be the best approach to solve this question? As soon as you look at the question, right? Would it be feasible to for you to jump to the statements and work, or would it be feasible for you to, put the question into one of the 4 buckets and then work? Definitely, right? It would be easier for me to square both sides. So most of y'all have taken back what I tried to say, right? And to classify questions into one of the 4 types. Perfect. I'm not even going into the statements, okay? This is, by the way, this is an actual GMAT prep question. Is A mod of A minus B greater than mod of A plus B? As soon as I see this question, I know that this question falls under type 4, right? So if it falls under type 4, I'm just going to square both sides and remove the mod. So this would be A minus B whole square is going to be greater than A plus B whole square. So A square plus B square minus 2AB is greater than A square plus B square plus 2AB. A square, B square would cancel out. So I'm going to get 0 is greater than 4AB, taking the 2AB to the right hand side, or 4AB is less than 0. So basically what you've done is you've broken down this entire question to is 4AB less than 0? Or in other words, the question is AB less than 0? So instead of jumping into the statements, right, it would be feasible for me to break down the question stem itself because it falls under the type 4 type. And then if I see the question now is AB less than 0, the first statement tells me AB greater than 0. It answers the main question with a definite no. So the first statement is clearly sufficient, AD. Right? The question is AB less than 0? The first statement gives me AB to be greater than 0. So answering the main question, it answers the main question with a definite no. And a definite no is a definite answer. So the first statement is sufficient, AD. Now the second statement tells me A less than B. Now think about it logically, right? For AB to be less than 0, I need A and B both to be of opposing signs, right? A can be positive, B can be negative, or A can be negative, B can be positive. But if I've been given information that A is less than B, both A and B can be positive, both A and B can be negative, or A can be positive, B can be negative, or vice versa, right? So clearly I know that the second statement does not give me enough information to say that AB is less than 0. It can be, it also may not be. So the answer here quickly is alpha. Okay with this? So you see the advantage of putting it in one of the buckets and then trying to proceed, because you're breaking down the question. The question becomes way simpler this way, right? And this is an official GMAT prep question. Okay, so I wanted to build up to this point, and I think if I remember right, it was Samjit who asked me, who wrote a question, typed out a question here, which was pretty much of the same kind, right? So here's your question, Samjit. Okay, I could not use the exact same question from the resource that you used, so I've just changed the variables around. Uh, I'm assuming that this is exactly the same question that you asked with the variables instead of a and b to be x and y, right? Just confirm on that so that we can continue solving. Samjit, if you're still there, is that the question that you asked previously? Because I can't search for your ping on the chat window. It's just too long. Samjit. Okay, so again, I'm going to give you 2 minutes, guys. I wanted to take 2 minutes, solve, give me an answer. The person who had asked this question is Himanshu. So Himanshu, if you're still there, I think this is your question, and it's with X and Y, not with A and B, right? I want an answer from everybody. I've just got 4 responses. See, always try to bucket it in one of the 4 types. If it doesn't fall under the 4 types, right, that's when you think about analyzing and plugging in. Okay, don't approach the question directly by plugging in every time. All right. So very simple question, right? Now, Himanshu, this is especially for you. Okay, mod of x plus 2 is equal to mod of y plus 2. So the first thing I would do is to square both sides and remove the mod. So that would be x plus 2 whole square is equal to y plus 2 whole square. Okay. So I have x square plus 4x plus 4 is equal to y square plus 4y plus 4. So clearly I can cancel out the 4 here, and I have x square minus y square is equal to 4y minus 4x, right? Now think about this, okay? Think about this. How can I, further simplify from here? Can I further simplify? I can just take everything to the left-hand side. X square minus y square minus 4y plus 4x is equal to 0. I can write this as x minus y into x plus y. I take minus 4 common. So if I take minus 4 common, it will be y minus x is equal to 0. If I take, so clearly this is x minus y into x plus y plus 4 into x minus y. I'm switching the signs because I want to pull out things common, is equal to 0. And I can take out x minus y common here. And I am left with x plus y plus 4 is equal to 0. So if I simplify, mod of x plus 2 is equal to mod of y plus 2, I have two possibilities. Either x minus y is equal to 0 or x plus y is equal to minus 4. And the question asked me to find out what is the value for x plus y. So keep in mind, I've already got an individual value of x plus y is equal to minus 4. For me to get a definite answer for x plus y is equal to minus 4, I need the statements to give me information so that I can discard this first solution of x minus y is equal to 0. Because if I'm able to discard the first solution of x minus y is equal to 0, I know that there can be only one possible value of x plus y, which is minus 4. Now think about this. What is the meaning of x minus y is equal to 0? X is equal to y. The first statement tells me xy is less than 0. Now think about it logically, right? If xy is less than 0, both x and y have to be the same sign. Both have to be of opposing signs. I will never, ever, ever have x to be equal to y. So this part of the solution is ruled out. I'm only left with the second solution, that is x plus y is equal to minus 4. So the first statement is sufficient to solve, AD. The second also is clearly sufficient to solve, because I need to have definite information to say that x cannot be equal to y, right? So if x is greater than 2 and y is less than 2, I can never have x to be equal to y. So again, the first part of my solution is ruled out, and I'm left with only one possible value of x plus y, which is minus 4. The second is also sufficient. The answer here has to be delta. Okay with this, guys? It's very, very simple. And I told you, right, that the question which Himanshu gave is a slightly tricky one, because you'll have to make sure that you analyze the question very, very carefully. When you break down the question, you get two possibilities: x is equal to y, or x plus y is equal to minus 4. But what happens, right? What happens here is, for me to definitely, the second statement is simple, right? X is greater than 2 and y is less than 2. If I take x to be greater than 2 on the number line and y is less than 2 on the number line, can x ever be equal to y? X will definitely not be equal to y, right? So I can discard the first solution. So if I can discard the first solution, I'm only left with the second solution, x plus y is equal to minus 4. So the tricky part of this question was for you to discard the first solution where x is equal to y, and I needed the statements to give me that information to discard the first bit, right? Because I had a ready-made value of x plus y to be equal to minus 4. Okay with this, guys? Okay with this, Benny? It's very, very simple. No, if x is greater than 2 on the number line, y is less than 2 on the number line, you can never have x is equal to y. Okay with this, Himanshu? Okay with how I solved this out and why I told you to square both sides and remove the mod becomes simpler, right? You can also think about using the number line and solve, but I think that would be slightly a little tedious approach. It would be easier for you to work this. You can't cancel x minus y on both sides, Akshay, then you're going against the rule of inequalities, okay? So, guys, you can't cancel x minus y on both sides. If I give you something like AB is equal to BC, right? Now, this is very, very basic algebra. If I give you AB is equal to BC, I just can't cancel the B on both sides and say A is equal to C. That's completely wrong. If AB is equal to BC, the only time you can cancel B on both sides is when they give you information that B is not equal to 0. If they don't provide you that information that B is not equal to 0, you just can't cancel the B on both sides, because if B takes a value of 0, A can be some random value 1498, C can be 1. 1498 into 0 is the same as 0 into 1, right? In this case, A is definitely not equal to C. So if at this point, right, if at this point you had cancelled out x minus y on both sides and solved it, then you're just overlooking one of the roots, which is completely wrong. How you're supposed to solve AB is equal to BC is this: AB minus BC is 0, and then take things common. So B is common, so A minus C is 0. So either B is equal to 0 or A is equal to C. That would be the solutions to that equation. Okay, you just can't cancel. In the first statement, x and y are -3. -3 into -3 can't be less than 0, right? Simple as that. All right. Okay with this, guys? Can I go to the next question? All of y'all? All right. Perfect. So here's question 5. Again, same rule applies. 2 minutes. We're going to have a discussion at the end of 2. Waiting for a lot more responses. I've got only 10 responses so far. A lot of a mixed bag of answers here. So let's see. Guys, see one thing. Okay, just learn one thing. If you're a little, hesitant or just thinking about, okay, whether your answer is absolutely right, if you have some inkling of doubt in your head, right, there's no harm in going the route of plugging in values. And remember what I told you. If you're plugging in values, you check for all types of values. You check for 0, check for 1, you check for negatives, you check for fractions. Right? Don't shy away from doing that, because not everybody would be very, very comfortable with the algebraic approach and the analysis approach of working, right? So try to make sure you juggle between all procedures of working. Any sort of doubt, if you're not able to proceed in an analysis way, plug in values. It's all right. Okay. So most of y'all, it's a very, very, very mixed bag of set of questions. Some of y'all have said B, a lot of y'all have said D, some C, some echo, nobody with alpha. So let's see. Fine. Now, what do you think would be the best thing to do in the, in the first step of the question itself? Is root of x minus 3 whole square equal to 3 minus x? I can rephrase this question to be, is mod of x minus 3 equal to 3 minus x? Isn't this okay? I can rephrase this entire question to is mod of x minus 3 equal to 3 minus x? Why am I rephrasing this question? Because I have the equation mod of x is equal to root of x square. So root of x square has to be equal to mod of x. And now think logically. For mod of x plus 3 to be equal to 3 minus x, x minus 3 has to be negative. Because mod of x minus 3, if I split it open, I'm going to get x minus 3 and I'm going to get minus of x plus 3, right? This is when x is less than 0. So I know for me to say that mod of x minus 3 is equal to 3 minus x has to be less than 0 or x has to be negative. So keep this in mind, okay? X has to be less than, x minus 3 has to be less than 0. Agree with me on this, guys? All of y'all? All of y'all okay with this? Okay with what I'm saying? Perfect. So would the first statement be sufficient? What did you get, Raj? What did you get? I'm just saying that mod of x is equal to root of x square, right? If mod of x is equal to root of x square, root of x minus 3 whole square can be written as mod of x minus 3, which has to be 3 minus x. Now what comes out of the mod of x plus 3 will be mod of x minus 3 will be x minus 3 when x minus 3 is greater than 0. And mod of x minus 3 will be minus of x plus 3, which is 3 minus x, when x minus 3 is less than 0 or when x is less than 3. Isn't it? So I'm just saying this entire question hinges upon the sign of this x. Can't I eliminate the root and square? I think again you're a little misinformed about the rules of inequalities, right? You just can't square both sides like that. You just can't square both sides because I don't know whether 3 minus x is positive or negative, right? And I told you root of x square is plus or minus x, isn't it? It's the definition of mod, right? Mod of x is plus x when x is greater than 0. Mod of x is minus x when x is less than 0. So mod of x plus 3 is going to be x plus 3 when x plus 3 is greater than 0. And mod of x plus 3 is going to be minus of x plus 3, or mod of x minus 3 is going to be minus of x plus 3 when x is greater than 0, when x minus 3 is less than 0. So obviously x has to be less than 3, right? Yeah, it can be equal to 0 also. Absolutely fine. No problem. It can be equal to 0 also. Absolutely fine. Right? I'm not denying that. So it can be 0 or negative basically, right? So would the first statement be sufficient, guys? Would the first statement be sufficient? Now I've broken down this entire question. To is x minus 3 less than or equal to 0? For a couple of people have said that it can be equal to 0. Yes, I'm not denying that. So will the first statement be sufficient? If x is not equal to 3, is that enough information to say that x minus 3 is less than or equal to 0? Definitely not. So BCE. What about the second statement? Would that be sufficient? Would that be sufficient to say that x minus 3 is less than 0 or x is less than 3? Would this be sufficient? Okay, for those who are telling me, yes, it would be sufficient. Yes, perfect. You know that x is going to be negative, right? Think about this. If minus x mod of x is greater than 0, just analyze this very, very carefully. If minus x mod of x has to be greater than 0, x has to be negative. Because this mod of x is a positive quantity, minus x into a positive quantity should give you greater than 0. So x has to be negative. So me having the information that x is negative, is it sufficient to say that x is less than 3? No problem. Think about it, guys, okay? It will definitely be sufficient, right? Because if x is negative, root of x minus 3 whole square, which is mod of x minus 3, if x is always negative, should always give me a negative output. Because negative minus 3 is still going to give me a negative value, right? So if x is negative, I know the output of mod of x minus 3, if x is negative, the output of mod of x minus 3 will always be 3 minus x. So the second statement gives me enough information to solve for the equation because I have information that x is negative. Okay with this, guys? Perfect. No, this was not that tough. It was pretty easy. The first statement is telling me x is not equal to 3, right? Now I need to say whether x is less than 3 or not, less than or equal to 3 or not. X is not equal to 3 does not tell me definite information that x is less than or equal to 3, right? It can be 4, 5, 6, 7 also. It can be 2, 1, 0, minus 1, minus 2 also. So clearly the first statement is not sufficient. Second statement is definitely sufficient because it gives me definite pieces of information that x is negative. If x is negative, I know x minus 3 will always be negative, and if it's negative, mod of x minus 3 will always give me an output of minus of x minus 3, which is 3 minus x. Okay with this, guys? You can always cross check. I told you, you can always cross check by plugging in values. Okay, so don't shy away from that if you're not getting the analysis of the question. Okay. All right. So since we're running short of time, I'm going to skip one challenger question and I'm going to give you one of the challenger questions. Okay. So I want all of you all to try this question, please. Here's a challenger question. Take 2 minutes. Give me an answer at the end of 2. Guys, make sure you remember what we discussed in terms of quadratic inequalities because it'll be easier for you to use the quadratic inequalities concept to solve the statements 1 and 2. Okay. So don't think about plugging in values here. That's going to be too problematic. Yes, Ritesh, you're absolutely fine. That's perfect. What you got is right. Good. So I see a good number of you all have given me echo as the answer, and that is the actual answer. So let's actually solve it. Okay, let's actually solve it. Let's see, how you would go about this. So the first thing in this question is mod of x minus 1 less than 1. So I clearly identified that this falls under the type 2 bucket that we discussed. That is when mod of x is less than a, right? The range will always be from minus a to plus a. So if mod of x minus 1 is less than 1, the range will always be from minus 1 to x minus 1 to less than 1. So I'm going to add 1 throughout. So the question is asking me, is x between 0 and 2? This is what the exact question is. I'm breaking down the question, and you'll realize, right, there's a particular pattern that you can get here, because on the harder questions, right, on the harder questions, you'll be forced to break down the question stem itself. Because if you work with the original question, it's going to be slightly tedious for you to get to an answer. So learn to break down the question stem itself wherever possible, right? So are everybody okay with the first bit, how I broke down the question? Perfect. So I'm going to work with the first statement. So the first statement tells me x minus 1 whole square is less than or equal to 1. So I'm going to say this is x minus 1 whole square minus 1 square is less than or equal to 0. I'm treating it as a quadratic inequality, so I can factorize it and solve. So this is a square minus b square. So a square minus b square is a plus b into a minus b. Yes, this is a, this is b, which is less than or equal to 0. So this gives me x into x minus 2 is less than or equal to 0. So I'm going to plot the roots on the number line. The roots are at 0 and 2. So I'm going to start with the extreme rightmost region, plus, minus, plus. I look at the right hand side of the inequality, it's less than or equal to 0. So the first statement tells me that the range for x has to lie between 0 and 2. But since it's less than or equal to, it has to be inclusive of 0 and 2. So the first statement tells me 0 is less than or equal to x, less than or equal to 2. But this does not give me enough information to say that x is always between 0 and 2, because x can also be equal to 2. X can also be equal to 0. So it's possible for me to get a contradiction. I can get a yes, I can also get a no. So the first statement is insufficient. The three possible answer choices are B, C, and E. I'm taking this question slow, guys, because I need you to understand how to solve this, okay? So everybody okay with the first statement? Everybody okay with solving the first statement? Perfect. All right. Now let's take the second statement, right? The second statement says x square minus 1 is greater than 0. So basically this is x minus 1 into x plus 1 is greater than 0. So putting things on the number line, x is going to be at minus 1. It's also going to be at plus 1. So plus, minus, plus. The right hand side is greater than 0. So I know x has to be greater than 1 and x has to be less than minus 1. So clearly this does not give me information whether x is going to be between 0 and 2, right? It can be, it need not be. So again, insufficient. Now I'm going to combine the two statements. And when you combine the two statements, the reason why I chose this question is because sometimes when you combine statements with inequalities, right, it always makes sense to plot things on the number line. See, the first statement tells me that the value of x is between 0 and 2, right? Inclusive of 0 and 2. And the second statement tells me that the value of x is greater than 1. So this is 1, right? And it's going to be less than minus 1. This is minus 1. So think about this, okay? When I'm going to combine the statements, I need the values of x to satisfy both statements simultaneously. So when I plotted both ranges for x, the only range which satisfies both statements simultaneously is the range of values from 1 to 2. And remember, you're including 2 here. So when I combine the statements, the overall range for x is going to be 1 less than x less than or equal to 2. Now, if I take this and I answer the main question, is x between 0 and 2? I get a yes if I take x to be 1.9. But I'm going to get a no because x can also be equal to 2. So the answer here has to be echo. Okay with this, guys? All of you all? Okay with this? Okay with how I combined the two statements, how I used the number line, plotted the ranges, and figured out what is the overlap between the two? Yes? So everybody okay with the fact that if you bucket the questions in one of the four types that we discussed, things become easier, especially when you break down the question, things become easier to solve with the statements, right? Perfect. So I think somebody had asked me this question previously, right? So I'm going back to this question here. So let me use a word file. Since we're running out of time, I'll just give you an answer directly. This is what you asked me, right? It was mod of x minus mod of x square, if I'm not wrong, is equal to 2. Just confirm, please. Just confirm if this was the question. All of y'all, can you please confirm if this was the question? All right, perfect. Okay, something else also. What is the value for x? I mean, looking at it only, you can answer this, right? What should be the value for x here? What do you think should be the value of x? Clearly, it should be 2, isn't it? Yes. So there are two ways you can look at it, okay? If you actually want to look at it and use numbers, that's one way. You can always plug in values, right? But plugging in values wouldn't be feasible because you'll realize, but after a time, that only one value is going to satisfy this equation 2 and 2. But let me break it down, okay? This is how I would break it down. Mod of x minus mod of x square whole mod is equal to 2, right? I'll keep mod of x square to be equal to y. So this entire thing becomes mod of x minus y is equal to 2. I'm going to split this open because it's type 1. So x minus y is equal to 2 would be one case, and minus of x plus y is equal to 2 would be the other case. Now I put back the equation that y is equal to mod of x square, right? So this becomes x minus mod of x square is equal to 2, and this becomes minus x plus mod of x square is equal to 2. Okay, these are the two equations that you end up getting. Now think logically, okay? Think logically. Whatever value I put for x in this equation, whatever value I put for x in this equation, I will never get a positive output. I'm always going to get a negative output here. Agree? Or a zero output. Yes? Whatever value I put for x, I can get a negative output, a positive output also if I use fractions, right? Or zero. I will never get a value. See, let me put it this way. Negative outputs, all negatives will work, right? If you take x is equal to 2, you're going to get 2 minus 4, which is 2. So I know I'm going to get negative output. If I put x is equal to 0, I'm going to get equal to 0. But if I put x is equal to some positive fraction, right, I know I'm going to get a positive output. But I cannot get a value for x when I substitute in that first equation x minus mod of x square equal to 2, which is going to give me the output to be equal to 2. Agree with me on that? For whoever asked me that question, do you agree with me on the fact that x minus mod of x square can never be equal to 2, right? In the first case. But in the second case, it's possible for me to have the value to be equal to 2. And you'll realize that in the second case, when you plug in values, right, the best thing to do, right, at this point is to plug in values in 4 cases. You can plug in 0, 1, minus 1. So you can plug in values to the right of 1. You can check for all positives to the right of 1. You can just check for fractions. You can check for negative fractions. You can check for negative integers. You'll realize that the only possible value, just looking at the equation, I know that is going to satisfy this equation is x is equal to 2. Right? So I can only solve for the second case. Yes, that's another way of looking at it. Mod of x square is always positive? Definitely yes. Perfect. That's another way to look at it, right? See, another way, Ramcharan, to look at this would be to understand the graph of y is equal to x square. If you understand the graph of y is equal to x square, right, it's going to be a curve, isn't it? And if I take that curve, it's going to be only 1, right? So I'm not going to go into the curve way of working. I'm saying you can solve all modulus questions if you use a combination of the types we discussed and also bring in the a logical aspect of analysis as well as plugging in values. Okay. So that's the entire concept of a modulus. In a value data sufficiency to find x, if I end up getting a quadratic equation using two options and get two values of x, will I answer C or E? If it's a value data sufficiency, Rahul, if I get two values for x, then it's not a definite answer, no? Take an example, okay? I'll give you a very simple example. If I ask you what is my name, right? The question I give you, what is my name? And the first data that I give you is my name is Aditya or Arun. I'm giving you two possibilities. Is that sufficient to answer the question, what is my name? Definitely not, right? So it's like that. It's exactly the same as that. If I have two values for x and the question is asking me what is the value for x, then definitely it's not sufficient because I can't get a definite answer. If it is a value data sufficiency saying is x greater than 0 and the two values that you get for x are all both positive, then you would say it answers the question with a definite yes. Okay, just keep this example in your mind. What is my name? My name is Aditya or Arun is not definite information to say what my name is, isn't it? All right. Any other doubts, guys? Any other doubts? I have exactly 5 minutes to cater to doubts. I've already taken the session for approximately 2 hours. So, any other doubts, guys? No problem, Ramcharan. Great. Any other doubts, guys? Any other doubts? Yes, Shikhar, tell me. One plus five. So what I would suggest, no, see, we have what I'll do is this. Okay, if you can go onto the Crackverbal website and check for the online course, right? The online course has some preview videos for quant. Okay, there are four preview videos, which is approximately I think 4 hours of videos that I have shot. Okay, so that entire set of videos discusses about data sufficiency in depth along with gives you strategies of problem solving and data sufficiency. Okay, so just make sure you go through that set of videos. It just go to the Crackverbal website, just go to the online course and look at the four preview videos under the quant section. If k is a positive constant and y is equal to mod of x minus k minus mod of x plus k, what is the value for y? Okay, x is less than 0 and k is equal to 3. Okay, perfect. So in this case, right, in this case of working, you'll have to use the number line. So what I would want you to do, right? Perfect. What is the max value for y? You can definitely find the max and min values with this. Shikhar, can you do me a favor? Can you just quickly send this question as a mail to prep@crackverbal. What I'll do is I'll write down the explanation for you the same way in a Word file and I'll send it to you. Okay. So the way you solve it is to use it on a number line. Okay, so if you can quickly type in that entire the mail ID is prep@crackverbal. That's the email ID that we provide to all students to get their doubts clarified. You can get the recording of the session by just mailing marketing@crackverbal. Okay, so they should provide you the recording over email. When do we use ZoneF? Whenever you're plugging in values, Ria. So whenever you choose to plug in values in a question, it's always better to use 0, 1s, then check for negatives, then check for fractions. All right. Guys, any more doubts? Quickly, another 3 minutes before I wrap up the session. Guys, if you have any specific question doubts, right, you can just send an email to prep@crackverbal. I will respond to it myself. Okay. Yes, marketing at Crack Verbal. You can just send in an email. They should. They will definitely send you the recording. Okay, guys. All right, fine. Okay, then I'm logging off. Good night. Take care. See you in 2 weeks' time when we have the quant module again. Okay. Good night.